microplate beer shaking parameters. So I'm going to tell you all some of our background, then the experience we did, the results we found, and how we concluded that. For the background, we're going to talk about biofuels, microbial physiology, advantages and disadvantages of microplate beer, and reproducibility. So what are biofuels and why do we need them? Currently we use petroleum as fuel, and it's really bad for the environment. It releases a lot of greenhouse gases when you combust it, and it has a limited supply. Alternative option is biofuels, where that comes from biomass, which is plant-based, and you can ferment biomass and produce large fuels such as ethanol. And this process is considered carbon dioxide neutral because all the carbon dioxide released can be used for plants to grow and then make more biomass. So it's a cycle. For microphysiology, we're working with Cerevisiae, which is piece right here. And the overall goal of the lab is to look at the user fermentation conditions that affect ethanol production, such as low pH, high temperature, high osmotic stress, and high ethanol concentration. And growth is often the first factor to be analyzed when you look at those. But how to research glucose growth? We can use many methods to look at growth. One of them is the spawning test, where you can dilute a culture and see how well it grows. And you can compare different strains and different dilutions, and as you can see in this picture, the fourth strain grew better than the second one. So this test is more like qualitative because you don't like numbers. Then you have colony forming units where you spread a plate, and then you have to count each unit, each colony one by one, so it's very labor intensive, but it gives you numbers, so it's a quantitative method. And then you have culture on liquid medium, where you inoculate with a real medium and look at growth by looking at the optical density, and that's the one we're using in our lab. So why use the plate beer? If you don't know what a plate beer is this guy. And the advantage of it is that you can have different environments, like different types of shaking, different temperatures. And you will also use a microscale liquid cultivation, which is from 100 to 200 microliters. And it saves time, effort, and material because in one plate you can have up to 96 cultures at a time. And it also reduces human subjectivity since the plate beer is doing all the work for you. And the amount of contaminant waste because again you're using a microscale liquid cultivation. And for the disadvantages is that you can only set one temperature when incubating, so if you're looking at many temperatures, you have to run the plate beer many times. So for reproducibility, there's no standard protocol when using the microplate beer. And in a previous study, they read 100 papers that have microplate beer in their procedure, and only 68% of them reported their shaking parameters, and 76 reported their growing times. But the results came very based on protocol. They did an experiment with different type of lids and different type of shaking, and when they looked at cell density, they see that depending on the protocol they were using, it affected the cell density and cell growth. So our research question: how do different types of shaking affect the growth of yeast? And our goal was to analyze how different types of shakings affect the growth of yeast when using the microplate beer by determining the minimal generation time, stationary phase OD, and reproducibility. So now the experiment we did with two, one that compared all shakings and one that looked at cell counting location. So we have 7 different types of shakings. One is no shaking, when the plate is staying still in the microplate reader for 24 hours. Then we have linear shaking, where you move in a linear horizontal motion. Orbital shaking, where you make a circle. And double orbital, where we make a figure 8. And for the last 3, we can have continuous shaking, where you shake for 24 hours. You would only stop when taking the OD readings. Or intermittent, where we shake for 60 seconds before each reading. For the experimental procedure, on day 1, we will inoculate a snap cap tube with a colony of yeast and TSP at 2% weight by volume glucose, and then incubated at 37 degrees Celsius with continuous shakings for 24 hours. Then on the next day, we get the same tube, get some of the culture and put in a spectrophotometer to get the absorbance and see how much cells we have. And by knowing the absorbance, we can calculate the inoculum that we were using. So we get the calculated inoculum, we get the TSP, 2% weight by volume glucose, and then transfer everything to 96 flow plate. And then we put the plate in a microplate reader, set up, and choose a type of shaking, and leave it there for 24 hours at 370. So I'm going to show you all the data that we would get from the software. It's a lot, I'm trying to understand it. But this is an example of what we would get. We have readings every 15 minutes, and we would have 96 columns, 1 for each well, and we can tell that each cell would have the absorbance at that time. So we would get that data, and to right, we would get a growth curve. And when analyzing it, we would focus on generation time in the exponential phase. Generation time is the time that takes the cell to double. And the exponential phase is when the cells are growing at a fast and constant rate. And OD 600 in the stationary phase, which is right here, which is when the rate of growth, and that is similar. That's why you have a linear horizontal line. So for our results, we saw that for generational times, most of the shakings had similar generation times, which was around 80 minutes. But our linear shakings had a really low generational times, which was around 30 minutes, so they were doubling way faster than the other ones. But even though that was happening, when looking at the OT at 24 hours, they all grew the same. So for our second experiment, where the cells were clumping in the well, I would pick 4 wells around the edges and 4 more in the middle just to recognize them. And each well would be divided into 21 sections, and at 0 hours and 0 hours and 16 hours, we would get absorbance for each section. And our results for that experiment, green is less cells and red is more cells. You can see that for no shaking orbital and no more orbital, you have more cells in the middle of the well, whereas in linear shaking, you have more cells around the edges. And we think that this is why we had such low generational time, because cells around the edges might be affecting the ability of the microplate reader to do the OT readings correctly. So, we've already concluded. Yes, so recap, shakings had similar stationary phases and generational times except from linear shakings. And linear shaking had a distinct generation times and clumping locations. So considering all that, we concluded that no shaking would be the best shaking to use because it would put less workload on the plate reader. And then we can set no shaking as a standard when doing experiments with industrial fermentating microbes. Now for future directions. It would be good to reproduce all shaking experiments using different speeds. Our previous research did that, and they saw that intensity affects the way the cell moves. And then we can look at covering types. As I mentioned earlier, that covering types are not being recorded, and when they did the experiments, they saw that it can affect the results. So the covering type that we can look at is no covering at all. The lid that comes with the plate, a sticker lid, and a felt lid. And when comparing those, we can look at the evaporation of the media and oxygen limitation, especially in this one because the sticker lid seals the valve, so you have limited amount of oxygen in there. And now for acknowledgements, I would like to thank Dr. Eve for advising me and for his guidance. And then Cody for being my lab partner this semester. Catherine for continuing the research and looking at programming types. And I for funding. Any questions? Alright, so anybody has any questions for Sophie? Yes.
So, my only question is if those movements were programmable or those were already included in the software.
Like we would, we can, when we would like put in the software, we can make a protocol and we can choose what type of music movements we would have, like the type of shakings.
Why do you think that they haven't been reporting, they haven't standardized the protocol for this before? Or like why hasn't it been consistent reporting on those two?
Maybe like they think that it wouldn't matter. Like, well, like when they did the research, it didn't matter, but now we did it again, and now we got like similar results, so it's still good to set a standard. It increases reproducibility.